Enthalpy of ionization, it is exactly reverse of electron gain enthalpy, or in other words, for enthalpy of ionization, energy is required to remove electron from isolated gaseous atom. It is always positive, I told you. In electron gain enthalpy, energy is evolved when isolated gaseous atom accepts electron and forms anion, and therefore electron gain enthalpy is the enthalpy change when 1 mole of isolated gaseous atom of an element accepts electron and forms 1 mole of anion. So this energy, it is called as electron gain enthalpy. As an example, you consider again isolated gaseous chlorine atom. So 1 mole of isolated gaseous chlorine atom when accepts electron and forms the anion, isolated gaseous chloride anion, whatever heat is evolved, that is electron gain enthalpy, and for chlorine it is minus 349 kilojoule per mole. So this is what is electron gain enthalpy. Now next term is enthalpy of solution. Now enthalpy change in which 1 mole of substance is completely dissolved in specific quantity of solvent to form its solution, it is called as enthalpy of solution. You know, at the time of formation of solution, suitable solute is added in solvent, and solute gets dissolved in solvent and there is a formation of solution. You consider the sodium chloride, and suppose 1 mole of sodium chloride solid, it is ionic compound. When it is added in water, water is a polar solvent, so sodium chloride dissolves in water and we get sodium chloride solution. In sodium chloride solution, cations and anions, first of all cations and anions are formed, there is a dissociation, and after dissociation these cations and anions are hydrated and we get hydrated cations and anions, and therefore sodium chloride dissolves in water, we get a solution. And during formation of this solution, for 1 mole of sodium chloride, whatever enthalpy change, that is the enthalpy of solution. For sodium chloride, this enthalpy of solution is 4 kilojoule. Most of the time enthalpy of solution is positive, but not necessarily all the time it is positive, sometimes it is negative also. And this is decided by two important forces or interactions, that is solute-solute interaction and solute-solvent interaction. Based on this fact, this value, enthalpy of solution, it may be positive or negative. Now, as I said, the enthalpy of solution, it is decided by, or it is the sum of the enthalpy of crystal lattice or enthalpy of hydration. So we are going to elaborate this point in detail. Now the exact value of enthalpy of solution for a given substance, it depends upon actually 3 types of interactions, but 2 are the major interactions, already I told. And the interactions are solute-solute interaction, solute-solvent interaction, and solvent-solvent interaction. Solvent-solvent interaction is minor. So first of all, we consider the solute-solute interaction. Now you know, in ionic crystal, solute particles are held together by strong intermolecular or intra-ionic attractions, and when solute or such a ionic compound is added to solvent, some energy, it is equal to lattice enthalpy, it is required to overcome these attractions. So first step is, or first important step at the time of formation of solution is the solid ionic compound gets converted into isolated gaseous ions, and whatever enthalpy change associated with this process, it is the lattice enthalpy and it is always positive. For sodium chloride, when 1 mole of solid sodium chloride, it gets converted into isolated gaseous cations and anions, whatever energy is required, that is lattice enthalpy, and for NaCl it is plus 790 kilojoule per mole. So this is one of the important step, and during conversion of ionic compound into isolated gaseous cations and anions, energy is required because there is a need to break strong intermolecular force of attraction between cations and anions, and to break bond energy is required. So this is the first interaction, that is the solute-solute interaction. This plays important role at the time of formation of solution. Now another minor interaction, that is solvent-solvent interaction. Actually solvent molecules are associated together due to hydrogen bond or dipole-dipole interaction, and some energy is always needed to separate solvent molecules by means of breaking these attractions. But as I said, this type of interaction is very minor. Now the second major interaction plays important role at the time of formation of solution, that is the solute-solvent interaction, and energy associated with this interaction, that is the hydration energy. So second step we are considering at the time of formation of solution, that is the hydration of isolated gaseous ions, and this is what is the meaning of the hydration enthalpy? The amount of energy released in the isolated released in hydration of 1 mole of isolated gaseous ion is called enthalpy of hydration. Enthalpy of hydration is always negative because there is a formation of physical forces between cations and anions and solvent. So consider again the sodium chloride. So in first step there is a formation of isolated gaseous cation and anion. When it comes in contact with water, cations and anions are hydrated, and we get hydrated cation and anion. Energy evolved, that is called as enthalpy of hydration. So for sodium chloride, enthalpy of hydration is minus 786 kilojoule per mole, and net enthalpy of solution, it is the sum of lattice enthalpy and hydration enthalpy. For example, enthalpy of solution for NaCl, it is equal to lattice enthalpy plus enthalpy of hydration. So for NaCl, lattice enthalpy is positive and it is 790 kilojoule per mole, and hydration enthalpy is negative, so minus 786, and when we take sum of these two values, the enthalpy of solution for NaCl is 4 kilojoule per mole. So always you keep in mind, enthalpy of solution for any solute, it is the sum of lattice enthalpy and enthalpy of hydration, and depending upon these two values, which value is greater, depending upon this fact, enthalpy of solution may be positive or negative. Suppose in case of some solids, during second step large energy is evolved, then the energy required to separate the cations and anions, in that case the enthalpy of solution will be negative. In case of sodium chloride, for first step more energy is required, and during second step less energy is evolved, so net energy change is positive here. Okay, so this is about enthalpy of solution for NaCl. For potassium chloride, KCl, the same concept is there. For potassium chloride, enthalpy of solution is plus 17.2 kilojoule per mole. One more term is there, enthalpy of dilution. Actually dilution means when one concentrated solution is converted into some other lower concentrated solution, then we say dilution. Suppose 1 molar NaCl is there. For 1 molar NaCl, when we prepare 0.1 molar solution, then we are diluting that NaCl solution. Meaning of this is dilution. So in this way one can dilute solution continuously, and at the end, when we add continuously water, at the end we get infinitely dilute solution. The enthalpy change that occurs when solution of one concentrated solution is diluted to form the solution of another concentrated solution, it is called as enthalpy of dilution. And the enthalpy change that occurs for the preparation of infinitely dilute solution, that is called as enthalpy of infinitely dilute solution. Enthalpy of infinitely dilute solution. So this is some other terms also which are just you must know about enthalpy of dilution and enthalpy of infinitely dilute solution. Okay, but question will be asked on this enthalpy of solution. So after completion of this section, now we are going to start the next section in thermodynamics, that is the thermochemistry. Now thermochemistry, it is the branch of thermodynamics which deals with the study of enthalpy changes in a chemical reaction. And you know, during chemical reaction, reactants are converted into products, and there is a breaking of old bonds in reactants, and there is a formation of new bonds in products. And to break a bond, energy is required, and at the time of formation of bond, energy is released. So overall study of energy evolved or energy absorbed during chemical reaction, that comes under the thermochemistry. So in thermochemistry, again you must know some terms, and the first important term is heat of chemical reaction or enthalpy of chemical reaction, that is delta H. Now what is the meaning of heat of chemical reaction? The amount of heat evolved or absorbed in a chemical reaction when the number of moles of reactants as represented by chemical equation have completely reacted is called heat of reaction. Actually during chemical reaction, as I said, reactants are converted into products, and whatever may be the moles of reactants and reactants may combine, but here at the time of formation of products, the enthalpy change associated with this process where reactants completely react and form the product, that enthalpy change, it is the heat of chemical reaction. As an example, you consider 1 mole of nitrogen combines with 2 moles of oxygen, and there is a formation of 2 moles of nitrogen dioxide. So during this reaction, whatever enthalpy change is there, that is heat of reaction. Or another example, suppose 2 moles of potassium chlorate is decomposed, and there is a formation of 2 moles of KCl and 3 moles of oxygen. Not necessarily there is a formation of 1 mole of product, or not necessarily there must be reaction. In reaction there is a involvement of 1 mole of reactant. Whatever moles of reactants and products are there, the energy changes takes place, that is the enthalpy of chemical reaction. So heat of reaction, it is calculated from heat content of products and heat content of reactants, and it is equal to heat content of products minus heat content of reactants, and therefore heat of reaction, it is equal to sum of enthalpies of products minus sum of enthalpies of reactants. So it is the energy difference between, or enthalpy difference between, products and reactants. So this is about heat of reaction.